Welcome back, everybody. We're going to move on in Chapter 11 to Lesson 2. We're going to do operations with radical expressions. So, in this lesson, you'll be able to simplify sums and differences, along with simplifying products and quotients. Language objectives would be that you'll be able to define like radicals and unlike radicals, and this new word, conjugate. Okay, let's define some of our terms. Like radicals are kind of like terms. They have the same radicand, meaning the number underneath the radical sign. That's the radicand. So, 4 square root 3 and negative 2 square root 3 are like radicands. Now, we could add them together and say that it would be 2 square root 3. All we do is add the coefficients. It's the same as saying 4x minus 2x equals 2x. Same thing. Unlike radicals, do not have the same radicands. So here's a radicand, here's a radicand. These are different. So you cannot add these together. 3 square root 11 cannot be added to negative 5 square root 7. So this is simplified. So let's practice. 4 square root 3 plus 1 square root 3 equals 5 square root 3. And then that would be your final answer. So in our last example, the radicands were the same, so we could add them. Well, sometimes if you see that they're not the same, don't give up. You need to see if you can simplify the radical. So remember, we say, what square can divide 45? And we know that 9 multiplied to 5 is 45. So I'm going to square root my 9 and square root my 5. So 9 times 5 is 45. I'll bring down the other stuff. 8 square root 5. And let's simplify. Alright, so the square root of 9 is 3. And I still have this square root 5 right here. Okay, now we can combine like terms. 8 square root 5 minus 3 square root 5 is 5 square root 5. 8 minus 3 is 5, and then my square root 5 stays. Done. Now we're going to use the distributive property and distribute a radical to the other two terms. So, same as before, you're going to do square root 5 multiplied to square root 8, and then you're going to do square root 5 multiplied to 9. Now, if you're multiplying a radicand to a radicand, they can share the same radical, and you can just say 5 multiplied to 8 is 40. That's the square root of 40. Plus, this will just be 9 square root 5. The 9 will go in front. We can break the 40 apart, so let's divide that by 4. 4 multiplied to 10 is the same as square root 40. So, I can break this square root 4, I can break that down to 2. So I have 2 square root 10 plus 9 square root 5. Now, I can't break this down anymore, and these do not match. So I'm done. I cannot add those together because they are not like radicals. Little side note, you might say, well, Mr. DeMars, could I break down the 8 before I multiply it by the 5? You can, and sometimes it makes it a little more difficult to solve or more steps. But I usually just do 5 multiplied to 8, and then I look at my product and then break it down if I can. But a person could break the 8 down ahead of time, but I recommend against it. All right, we just did distributive property. So now we're going to do FOIL, which is basically distributive property twice. So we're just going to take that 6 square root 6 and multiply it to both of those. And then we're going to take that negative 3 square root 21 and multiply it to both of those. So here we go. All right, take a look at what I did here. I just basically showed my multiplication. Square root 6 times square root 6. Then the square root 6 multiplied to square root 21. Then I did negative 3 square root 21, multiplied that to square root 6. Lastly, I took negative 3 square root 21 and multiplied it to square root 21. Now, when you do this, remember, if they're radicals, they can share the same radical. So we have 6 multiplied to 6. Now, if it's easier for you, you can say 36, and you can say, what's the square root of 36? And the answer is 6. Or you can circle pairs. If I have 2 6s inside, that's a pair, so I can bring out 1 6. Let's do our next one. Our next one is 6 multiplied to 21. You could say 6 times 21 is 126. Or what you can do is break 6 apart to 3 times 2, and then break the 21 apart to 3 times 7. Okay, so 21 is 3 times 7, 6 is 3 times 2. When I look at this, I can pair up my 3's. My 2 and my 7 will stay, but I can bring out 1 pair of 3's. So this is going to be 3, and then what's left inside, if I multiply those together, I get 14, 2 times 7. All right, let's move on. The negative 3 will just kind of stay there, and then I have this 21 times 6. If you have 21 times 6, and you already did it, you can definitely go like this and look at your answer before. Your answer before was 3 times 3 times 2 times 7. Now, I'm going to pair up these 3's and take one of them out. But there's already a negative 3 here, so I have to multiply them. Negative 3 multiplied to 3 is negative 9. And then I have square root of what's left, 14. 2 multiplied to 7. We'll get back to this in a second. Lastly, I have square root 21 times square root 21 here. So the 3 will come down. The 21s will share a radical. And if I have 2 of them, I can circle that and have one of those come out. So I'm going to bring the 21 out. So all I need to do now is negative 3 multiplied to 21 is negative 63. So I'm almost done. All right, here we go. My answer will be 6 plus, I can do 3 square root 14 minus 9 square root 14 is going to be, I'm going to start over, 6, and I'll say 3 square root 14 minus 9 square root 14 is negative 6 square root 14, and minus 63. Now, this 63 and the 6 can be put together, so my final answer will be negative 6 square root 14 plus 57. If I put negative 63 with 6, that will give me plus negative 57. Sorry about that. Plus negative 57. All right, one of our vocabulary words was conjugate. Our conjugates are the sum and difference of the same two terms. Here's an example of conjugates. So square root 5 plus square root 2, square root 5 minus square root 2. I'm going to try and have you remember something here. Do you remember in chapter 9 we had x plus 3 multiplied to x minus 3? And when we did that, we ended up with x squared minus 9. The middle disappeared. Well, that's what we're going to do here with this, because remember the rules of radicals. The rules of radicals say that you cannot have a radical sign in the denominator. And here I have 2 of them. And I cannot simplify. So here's how I'm going to get rid of that. What I'm going to do is multiply by the conjugate of square root 7 minus square root 3. That would be square root 7 plus square root 3. Now, whenever I multiply to the bottom, I have to multiply to the top, because basically I'm multiplying by 1. So, here's what I did. I set this up here, and I'm going to set this up here. Now, let's do our conjugates, or let's do our difference of squares. Well, this is going to be square root 7 basically squared, because it's square root 7 multiplied to square root 7. And what you get is that's the same as 7 times 7, which is the same as 49. And what's the square root of 49? 7. So now it's not in the square root anymore. Okay, then let's square this. So if I square root 3, that's like saying negative square root 3 multiplied to positive square root 3 gives me negative square root 9. So what's the square root of 9? 3, but the negative stays there. So I basically have 7 minus 3. So what happened? These were freed. They're freed. They're out of jail. So 7 minus 3 is 4. All I have to do now is distribute my 8. If I distribute my 8, I get 8 square root 7 plus 8 square root 3. So my final answer, that's going to go on top of 4. My final answer, if I look at it, it looks like I'm done here. 8 square root 7 plus 8 square root 3. But if I look closely, this 4 can divide into both of those 8s. So really, what I need to do is 4 goes into 8 twice. 4 goes into 8 twice. Goes into itself once. So my final answer is going to be 2 square root 7 plus 2 square root 3 over 1, which we don't need to write. But that's my final answer. Let's do 4 more examples. So distributive property. So we're going to do 4 square root 2 multiplied to 2. So when I multiply this to this, I can take the 2 and move it, commutative property, over with the 4. So 4 times 2 is 8, and right now I have 8 square root 2. Next, before I start here, if I look, I know that the square root of 4 is 2, so what I could do is cross this off and make it 2, and then just do 2 multiplied to 2. That's 4. So now what I can do is do 4 square root 2 times 4. So if I do 4 square root 2 multiplied to 4, the two 4's will multiply each other, and I get 16 square root 2. Okay, 4 times 4 is 16, square root 2 stays. Can I add these together? Well, yes, I can. 8 square root 2 plus 16 square root 2 is 24 square root 2. Let's move on to our next question. Here, I can multiply each of these by 8. So that's what I'll do. I'm going to multiply this by 8 and this by 8. And when I do that, I end up with 16 square root 5 plus 40 square root 2. Because they're different radicals or radicans, I'm done. I cannot add those. All right, number 3. I have square roots in the denominator. I must get rid of them. So I'm going to multiply by the conjugate. So I'm going to do square root 7 plus square root 3. And then I'm going to do square root 7 plus square root 3 on top. Okay, let's multiply. Remember, when I multiply these two, I end up with the square root of 49. And then I do negative 3 multiplied to positive, gives me a negative square root 9. Okay, 3 times 3 is 9. And if I were to square root 49, I get 7. If I square root 9, I get 3. So I end up with 7 minus 3. Just like before, I end up with a 4 in the denominator. A shortcut is, basically you end up with 7 minus 3. Because when you square these, the radicals disappear. Now, I'm going to look this time before I start. I have a 5 on top, and it's going to multiply to the square root 7 plus square root 3. So what I can do is double check. Can 4 divide 5? No. So let's just distribute, and we'll be done. 5 square root 7 plus 5 square root 3. There's my answer. I'm done. All right, let's try one more. We have square roots in the denominator, so we need to get rid of those. So we're going to multiply by the conjugate. So instead of minus, we're going to say square root 2 plus square root 7. And whatever we write on the bottom, let's write it on the top. All right, here we go. So if you remember the shortcut, this multiplied to this is really square root 4, which just brings us back to 2. And this multiplied to this is really 49, which when you square root it, it's back to 7. So I end up with 2 minus 7. So my denominator is negative 5. I need to do the numerator now. I'm going to look, can negative 5 divide 7? It cannot. So all I need to do now is take my 7 and distribute it to each of these. Here's what it looks like. It will be 7 square root 2 and then plus 7 square root 7. I'm done. Okay, here are the practice problems. Bring any questions you have to class next time we meet, and remember to use the conjugate here. Take care.